Hello, everyone, and thank you for joining us this weekend for the National Building Code of Canada Part 9 webinar. My name is Camille Rivard, and I am a Program Officer at the Royal Architectural Institute of Canada. This course is presented by Jensen Hughes, global leaders in safety, security, and risk-based engineering and consulting. The webinar is taught by Amal Tamim, Senior Consultant at Jensen Hughes. With more than 25 years of combined national and international experience, she is a firm believer in knowledge transfer, specifically in the area of building safety and building code application. She has led multiple code seminars and training workshops around the world, including a 35 hours NBCC 2015 training workshop. We will start with Module 3. Over to you, Amal.
Thank you, Camille, and good morning, everybody. Hopefully you have had a good rest last night and you're ready for today's marathon of Part 9, Module 3 and Module 4. We're gonna cover a lot of concepts, and but before we start that, I would like to get your feedback on quizzes for Module 1 and Module 2. And remember that we are being recorded. So go ahead. I'm waiting for your answers. I'm hoping that I'm going to get the questions regarding one question in the quiz. So Beryoska, go ahead.
Hi, hello, good morning.
Good morning.
Or good day, good afternoon. I do have a question about Module 1 yesterday.
Yeah.
So question number 3 said a party wall must be designed as a firewall.
Okay, good. That's the question I was hoping you guys will ask me about. So yeah, we did discuss that yesterday. And the party walls, one of the problems of this question is that all party walls must be designed as firewalls. Now, within the context of Part 9, we looked at the party walls in terms of fire resistance and construction as firewalls when they are located on a property line. So that's for the first problem with the question is that the question did not address what is the location of the party wall, because if you look at the definition of party wall, it could be located. Does not necessarily need to be located on a property line because in leased spaces within buildings, you can have a party wall between two units. So for two owners, but the definition. So that's one problem with this question is that it's kind of confusing to understand what is where it was going. The second part that is confusing in that question is, so if we assume that the question in general is talking about all party wall. So if it's talking about all party wall, not necessarily they are not all to be designed as firewall. But in the context of Part 9, the one we covered it, we looked at it as Part 9 for party wall on a property line. So the second part, so if you assume that the question is related to party wall on a property line, then the building code in Part 9 definitely says that all a party wall on a property line shall be constructed as firewall. However, it does give us an exemption, and that exemption allows it to be constructed for certain types of residences, for certain types of occupancies to be constructed as fire separation. So we have a problem with that question is that it is generic enough, and it does not say in residential buildings, all residential buildings in the question.
No, it doesn't.
No, it doesn't. So you got to be careful in terms of what the requirements for party walls and the definitions and what that question is. So as long as you have gotten the proper requirements in the code that says all party walls on a property line for dividing up a residential units under certain conditions can be designed as fire separation, then we're okay. And because we are in a context of Part 9, we're looking at party walls on a property line. Maybe it should have said that in the questions, but it didn't say it. So they should be designed as firewalls. And then there are exemptions to it, and the exemptions are for specific conditions. So, and and in that case, you qualify your answer for that. Unfortunately, the LMS system does not allow us to do it. But if you understand the concept and you understand the exceptions, that's why I wanted to know that people have a problem with this question because of the general approach to party walls. So if you said you didn't understand it, that's great, because it's because you understand the different concepts that go into the application of the provisions of fire separation to party walls and the use of fire separations in lieu of firewalls in residential units.
I think, I mean, that answers the questions, but still, I mean, you can have the same property to be divided by the party wall with a number of residential or dwellings on both sides, but all being within the same property. But there is a party wall in between them with a fire rating of 1 hour.
With a party wall I mean, that's what we're saying, is that party walls can be party walls not located on a property line. So when we're looking at party walls on a property line, they should be, and that's what the question is missing. It's missing the portion on a property line. So what I'll do is we'll make sure to fix it on a property line.
Okay, thank you.
Any other questions related to the quizzes?
I have one more if nobody else is going to ask.
Yeah, sure, go ahead.
So I have a question regards to the windows and doors and skylights. Yeah. I got this one incorrectly, even though when I went there second time, I see why I answered incorrectly. However, I followed these references to other sections of the code and I ended up in notes.
Yeah.
And I was looking at note A9.7.4.2.1.
Let's
standards.
Let's take a look at the note. What is that?
9.7.4.2 and then 1 in brackets.
Oh, it won't show me.
That's appendix.
Is that the way it is written? And then A dash, right?
That's right. So that's that reference there.
Yeah. All right. It's not willing to go to notes, so we're gonna go to like this. Okay, Canadian requirements and the harmonized standards. Is that it?
Yes, I mean, it lists these standards, but then below it says, it talks about basically about the standards, but also there is a sentence that says compliance with these standards is not required by the code. The references are provided information purposes only. I don't know how and why I ended up there and got caught up with that sentence. So
okay, let's go back to the question itself. Let's go back to the questions. I am here, and it is which module? The question for module 2, was it?
Sorry, it was module 1. I was wrong.
Module 1. Okay.
Question number 9.
9.
So there are 2 standards that are applicable, and that's fine. But then again, I went into appendix and I found this sentence that says that the compliance with these standards. So I'm not sure which standards are they referring to. That it's not code requirement.
Okay, well then it's a different context. You need to make sure at the note where it is standards referenced by the code. So it says the reference by the code for windows and door. These contain some specific Canada test criteria and all that. These are Canadian requirements and harmonized standards which are referenced in the code. Okay. Then that for excluded products, there is some other products. The harmonized standard defines the limit of the application of the standard with respect to various types of fenestration products. A list of exemptions to the application statement identified a number of standards that apply to excluded product. Compliance with those standards is not required by the code. The reference are provided for information purposes only. So sometimes here it's talking to the standards, about the standards and the way they exclude certain products from the standards, and basically they tell you that that's information only. The way that you apply the standards is as the code requires them. So if the code says you apply the standard to such and such products, you apply it to that. And if those standards exclude certain products, then you cannot apply the standards to those products. However, you only apply it to the ones that are referenced by the code with the understanding of the exclusion. The code is not going to list for you everything that is not that's excluded in the product. So I think that's what it is.
Sure. Yeah, I think I kind of realized that later on, and I found but anyway, I was a bit confused with that whole sentence there, because to me, well, if they're excluded, of course that wouldn't be required by code, then why would you even mention that? So
exactly.
Okay, thank you.
Yeah, okay. Any other questions from anybody on the
Yeah, I have a question.
Go ahead, Alberto.
Yeah, so it's regarding to quiz module 1. It's question number 4, which says a care or B3 occupancy with no more than 10% can sometimes be a Part 9 building under specification conditions.
Yes.
So I couldn't find the information on the Part 9, but I did find it on 3.1.2.5. So I want to know if this information is appears.
Oh, definitely. I mean, yeah, it is definitely in Part 9. It was also, we talked about it in presentation related to the occupancy and fire separations. Take a look at the application. Let's see, it's for fire protection. So if the easiest way to find it is, let's go to, what is that, convalescent?
Care occupancy or convalescent, yeah.
Yeah, so we were, as residential occupancy is 9.10.2.2. Take a look at 9.10.2.2. Okay.
Okay.
So that's where it's referenced.
Okay. Okay, thank you.
You're welcome. Anybody else? You guys can see, like, my backup is the code, and I use the tables of contents. I use the word search if I have the electronic copy. If I don't have the electronic copy, I will go to the table of contents, and for sure we're all not magically we're going to memorize the building codes, you know, page by page and article by article, but definitely we have the tool to look up for that information. Yes, Matt?
I have a question for module 2, question 4.
Okay,
it's about access panels for fire department access don't need to be provided for houses.
Yeah.
So I went to 9.10.20.1.
For, okay.
And then I see number 3. There's an exception for buildings containing dwelling units where there is no dwelling unit above another dwelling unit.
Yes.
So that means they're required, right? In the case of like a triplex or something?
Yes.
So would the question be true?
Okay. Access panel for fire department need not be provided for houses. So the question is related for houses. It's not, which is an independent, basically, home. Independent dwelling, not, I didn't say dwelling. So if it was dwelling, then you have to kind of put some limitations to it. But if it's for houses, then it's different. Then it is true. Okay.
I guess we just don't have like a definition of house, right?
Of house, right. But as I said yesterday, for the purposes of this, the house is independent, is an independent entity. It could have, if once we start using a secondary unit, we start calling it a dwelling. You know, residential with 2 dwelling was a secondary and a primary. But they don't say primary, but it's the main dwelling unit and the secondary units.
Okay,
so
thanks.
That's the only case we have houses. Yeah, Alberto, you have a question?
Yeah, and it's regarding to module 2 as well. It's question number 7, which says construction of exterior walls of all dwellings may be based on the provision of 9.10.15. So which is false.
Which is where are you now? Oh,
question
here. Okay.
7.
Yes.
Right. So I get a little bit confused on the application. So could you explain a little bit?
Yes. So if we go to 9.10.15.
Yeah.
And let's do that here. So the question was, let me see the questions.
Construction of exterior walls of
all dwellings may be based on provisions of 9, 10, 15. Okay, let's think about dwellings. When can you use 9, 10, 15? Can you use 9, 10, 15 for buildings that have dwellings with other occupancies? Right? So let's go back to when we said the application of 9, 10, 15, this subsection applies to what? To buildings that contain only dwelling units.
Only dwelling units, yeah.
And have no dwelling units above another dwelling units. So that means it does not apply to all dwellings. It applies only to dwelling units, buildings having dwelling units with no dwelling unit above the other dwelling unit.
With this condition.
Yeah, or it can also be applied to houses. Houses with a secondary unit or not, that's what it applies to. So that's why not all buildings with residential units can be designed to 9, 10, 15 because it's such a generic statement. You cannot apply it that way.
Yeah, but also not for all houses, only for houses with a secondary suite.
No, it's all houses because, you know, a house is a dwelling unit. And so it's parts of dwelling units. It goes into, you know, dwelling units can contain any types of residential buildings. So if you have a house with a secondary unit or not, you can design it in accordance with 9, 10, 15. Remember, house is included in under dwelling. House is like dwelling covers everything, and house is an independent residential building on its own. So you can, whenever you state residential dwelling unit or houses, a house or a house with a secondary unit, then that applies to it. So that's clear. All right.
Okay. Thank you.
Okay, sure. Anybody else? Okay, we're done with the quizzes. So we're on module 3. So we're gonna go start module 3. As usual, the presentation is protected by copyright laws. Production, distribution, and display and use of the presentation without written permission by Johnson Hughes and the Royal Architects Institute is not permitted. Again, these slides are only meant to be cue points, which are expounded upon verbally by me and are not meant to be comprehensive statements of the literal application of the codes or of the standards and their interpretations. So it is advised that the information learned today is used in conjunction with the applicable codes and the standards. This is not a course for designing houses or small buildings. This is to permit you to identify the proper provisions, navigate the codes, navigate Part 9, identify the concepts and what some of the provisions related to these concepts. So we're going to do our best to provide you that information today. But there's no replacement to reading the codes and going through the resource material that we identified for you. You've known me from yesterday, so I'm not going to repeat and present myself again. We're going to go through today's. We're going to talk about the building envelope and construction materials and systems. Remember, when we're looking on the building codes, remember to tab all your tables of contents. If you have the bound copy, if you have the binder copy, make sure that you use the tabs provided with them to identify the different divisions, the different parts, the different sections, the different tables, and the notes area, as well as the attribution tables. So the appendices also. We will use division A always to identify the application of the codes. We are looking at division B also because it is, as we have seen yesterday, division B applies to part 1 part 3, part 4, 5, 6, 7, and includes the appendices C and D as well, and includes the part 9. And sometimes part 9 is going to refer us to different parts under division B. So, and division C applies to part 9 building. In the volume 1 division A part 1, we have all the definitions and abbreviations. We're looking also at the reference documents, the standards that are used in the code, and some of those standards will refer back to the sections where they are used. So if you have some reference to a standard, a neat thing to do when you're going to let's go to 1.3. That's in 1.3 of Division B. That one has all the reference documents and organizations. In volume, I would like to go there first. Reference documents and organizations. Reference documents. So next. So this is a generic one where it talks about the application of the reference documents. We saw that at the beginning of part 9, where you apply it. The provision of documents references is code of any documents referenced within those documents apply only to the extent that they relate to buildings. An objective functional statement attributed to the applicable solution of division B where the documents as referenced. So it's as referenced by the code that you use the standards. Where a provision of this code references another model, national model code, the applicable objective functional statements shall include those that in the referenced national model code. So we know, objective functional statements will be coordinated between national model codes. In case of conflict between the provisions of this code and those of a reference document, the provisions of the code shall govern. So this is a critical concept to remember, and this is something that we will deal with when we're dealing a lot of the material standards that we're going to see during the day today. Applicable additions, we talked about that yesterday. Where documents are referenced in the code, they shall be in accordance with the additions designated in subsection 1.31 of Division B. Okay, 1.3. So when we're going through 1.3, one of the things that you could check if you are not sure about where a standard is referenced in the building code, whether in part 9 or other parts, and you know it's something related to performance of building materials or equipment, you're gonna go back to the code reference. You're gonna come back to the issuing agency, so the publishing house, or that publishes the standard, and the name of the standard with its number, the title of the document, and what's neat in table 1312 is that it's going to give you the code reference where that standard is name is stated, and so that's one area that you could use to go back to when you've got a question related to a specific standard and you don't know where is that reference. You forgot what it is reference, what it relates to. You can come back to this table, you can go back, and then you can go to the code section or the article that references it. As you can see, there is a reference. The reference standard, it's got its year of when it is published. So that gives you also the applicable, the addition of the standards that is applicable here. If it is not listed, it's all the changes to the standard up to 2017. I saw the up to year 2017 changes to the standard. But most of the time, most of the standards are going to have associated year with edition that is referenced, and you use the one that is listed here as the applicable edition. In volume 1 division B, there's also the climatic and seismic data. We're going to work with those today. We've seen them yesterday in terms of some of the elements for the application. This one is related to the application, but in the appendix, as we have seen here in the appendix of division volume in volume 1 and the appendix C in volume 1. If in division B, that's one of the standards that what we're going to be using for the performance of the materials and climatic data and seismic information for structural design. The application related to climatic and seismic data, we can take a look at it, is 113. Okay, the climatic and seismic values I'm reading here, 113 climatic and seismic data. 1131 talks about the application of climatic and seismic values required for the design of buildings under this code shall be in conformance with the values established by the authority having jurisdiction, or in the absence of such data with sentence 2 and the climatic and seismic values in Appendix C. So what's going to happen if you are in a province and that province has its own climatic data, the code tells you to reference those that are the climatic data that's published and established by the authority jurisdiction where you're working. Otherwise, if the authority having jurisdiction does not require, does not publish and does not say what's climatic data to use, then you can use those that in the National Building Code. The climatic and seismic, and that applies also to seismic values. And all the data that are published in building code, in the national code, are relate to outside winter design temperatures determined for climatic data, are those listed for January temperatures where they are 2.5% of the values, and we can go over that later on. And the depth of frost penetration, when you're looking at frost penetration, is based on the local experience. So these are for when you're looking at foundations and design of foundations, we're looking at frost penetrations. So this is general application information in 113 related to climatic and seismic data. It's a term is symbols, definitions, referenced organizations. We covered that. Okay. Any questions on those application sections, generic sections, division B that apply to part 9 and some of the tables? All right. I've identified a lot of in the table of content here. I've put it for you for the NBC 2015 in part 9. We're going to look at different areas from excavations, dam proofing, waterproofing, drainage, footings and foundations, floors on ground, crawl spaces, roof spaces, materials and systems equipment, glass provisions, masonry, insulating concrete, form walls, not in contact with ground, masonry and concrete chimneys and flues, fireplaces, wood frame, construction, sheet steel stud wall, framing, heat transfer, air leakage and condensation control, roofing, and then cladding, stucco, interior walls, ceilings, finishes, flooring, garage, and carports. So these are all provisions that you were gonna that apply to building envelope provisions, as well as construction materials and systems. So let's take a look at building envelope. So what is a building envelope? These are, I gave you the where I got those pictures is from the Energy Star program. When you're looking at the building envelope, you're looking at protection from the exterior environment, so and thermal performance. So what constitutes the building envelope? There is no definition, formal definition in the building code for the building envelope. However, when you're looking at the notes and the guides and the notes, whether it to part 5 or to part 9, you'll have a pretty good idea what constitutes the building envelope. It's materials, elements, components, and assembly that separate indoor spaces from the exterior environment and separates the ground from the ground, and those that separate conditions from unconditioned spaces. So basically, when we're looking at the building envelope, we're looking at typically at this is the building envelope. However, for protection from precipitation, we're looking at the protection of the whole building, and from water ingress, we're looking at the protection of the building from from all around the building exterior. But in terms of other performance, from thermal performance, And comfort, this is where we're looking in terms of the building envelope. And so what are the materials and elements? What the building envelope is constituted of materials, elements, and components that fulfill multiple functions with regards to withstanding structural loads, heat transfer, air leakage, vapor diffusion, protection from precipitation, surface and groundwater loads, and accommodate movements and resist deteriorations. So these are all different functions that can be fulfilled by a single element or a component, or one element may have a single function. So they can have multiple function or a single function. The performance of the building envelope is also impacted by other subsystems which relate to the heating, cooling, and ventilating equipment in the building, the plumbing and electrical systems. These are impact basically the interior conditions, and the interior conditions also impact how the envelope behaves, and the envelope materials and elements behave. Part 9 includes specification for materials, components, construction systems, and equipment of the in the building envelope and within the building. So some of the definitions we have are air barrier systems are the assembly installed to provide a continuous barrier to the movement of air. So go back. Do you know where we find the definitions, everybody?
Volume 1.
That's volume 1. Great. Okay. So in volume 1, we have definition also for vapor barrier. The elements installed to control the diffusion of water vapor. The conditioned space is any space within a building, the temperature of which is controlled to limit variations in response to the exterior ambient temperature by the provision of either directly or indirectly of heating or cooling over substantial portions of the year. So that's the definition of conditioned space. Bearing surface is the contact surface between a foundation unit and the soil and rock upon which it bears. Groundwater, these are some of the elements that's going to be impacting the design of our Part 9 buildings. Freestanding body of water in the ground, groundwater level, the top surface of a freestanding body of water in the ground, perched groundwater, freestanding body of water in the ground extending to a limited depth. Excavation, it's the space created by the removal of soil, rock, or fill for the purposes of construction. So part 9 is going to go over, from the excavation to the roofing, and in order to tell you how to design a building under part 9. Add freezing is addition of soil to a foundation unit resulting from the freezing of soil water, and this is also called a frost grip. Frost action is the phenomenon that occurs when water in soil is subjected to freezing, which because of the water ice phase change or ice length growth results in a total volume increase or the buildup of expansive forces under confined conditions or both, and a subsequent thawing that leads to the loss of soil strength and increased compressibility. So so with the design of the footings, the foundations of the building will be impacted by a lot of these elements, and that's why the building code is addressing their definitions. We have also the definition of rock, of soil, of fill. So for the rock, it's that portion of the Earth's crust that is consolidated, coherent, and relatively hard, that is naturally formed, solidly bonded. It's a mass of mineral matter that cannot readily be broken by hand. So it's the most solid element that you can place your home on. The soil is that portion of the Earth's crust that is fragmentary, such some individual particles of dried sample may be readily separated by agitation in water. It includes boulders, cobbles, gravel, sand, silt, clay, and organic matter. Fill, it's soil, rock, rubble, industrial waste such as slag, organic material, or a combination of these that's transported and placed on a natural surface of soil or rock or organic terrain. It may or may not be compacted. I mean, we have also definitions of foundation and different types of foundations we can have for a building. The foundation is the system of arrangement of foundation units through which the loads from a building are transferred to supporting soil or rock. So now we have our building, we have its foundation, and the foundation can transmit the loads from the building onto the supporting soil or rock. Foundation unit means one of the structural members of the foundation of a building, such as a footing, a raft, or a pile. So now we know that the raft, footing, pile are part of our foundation, and those transmit the loads from the building to the soil or rock underneath. The deep foundation is a foundation unit that provides support for a building by transferring loads either by end bearing to soil or rock at considerable depth below the building. So this is a very deep foundation, or by adhesion or friction, or both in the soil or rock in which it is placed. Piles are the most common type of deep foundations. So either you end bear it to soil and rock at considerable depth below the building, so the building goes down with walls, or it goes down with piles, to deep in the soil or rock. A shallow foundation is a foundation unit that derives its support from the soil or rock located close to the lowest part of the building that it supports. So the shallow foundation relies on the soil for support from the lowest part of the building that it supports, and in opposition to deep foundation. A pile is a slender, deep foundation unit made of materials such as wood, steel, or concrete, or a combination thereof, that is either pre-manufactured or placed by driving, jacketing, jetting, or screwing, or cast in place in a hole formed by driving, excavating, or boring. Cast in place piles are often referred to as caissons in Canada, and this is some of the jargon that is introduced in the code. Other areas that we consider when we're doing design of buildings, we look at plenums, a chamber forming part of an air dart system. With the floor area, we understand the concept of the floor area, and the appliances are the device to convert fuel into energy, and it includes all components, controls, wiring, and piping required to be part of the device by the applicable standard referred to in this code. So we started looking at those for air conditioning and heating yesterday, and ventilation, but when we're looking at heating and air conditioning, we're looking at the device to convert fuel into energy, and also for hot water, also for heating water. So we're looking at any device that convert a fuel into energy, and it includes all components, controls, wiring, and piping required to be part of the device by the applicable standard referenced by the code. So if you go to 9731, performance of windows, doors, and skylights, which are one element of the envelope. So in terms of the general performance of window, doors, and skylights, 9731. Windows, doors, and skylights and their components separating conditioned space from unconditioned space or the exterior shall be designed and constructed and installed so that when in the closed position, they resist the ingress of precipitation into interior space, they resist wind loads, they control air leakage, and they resist the ingress of insects and vermin. The compliance with the performance requirements of above shall be demonstrated by complying with the requirements in subsection 9.74 or 975 and subsection 976. Otherwise, you can design them and construct them in conformance with part 9. So the building code tells you if you don't want to design in accordance to part 9, you go to part 5. And that's specifically for the performance of windows, doors, and skylights. Let's take a look at the 9731 in detail. Just make sure that we get that first concept, because we're going to see that again and again for different components of the building envelope. 9731. There you go. Okay, so 9731, we see that there are exceptions to this. The skylights and their components shall be designed, constructed, and installed so that they resist snow loads. Unlike windows, doors, and skylights and their components separating conditioned space from unconditioned space, or the exterior shall be designed and constructed and installed. So design, construction, and installation all three actions, all three phases of putting together a building assembly, a component from manufacturing to design to installation, or to construction, design, construction, and installation. All those you need to make sure that all in that process, the final installation will be able to resist the ingress of precipitation from the interior space into the interior space, resist wind loads, control air leakage, resist the ingress of insects and vermin, and the forced entry only where required, so it's not all the time, are easily operable when not intended to be fixed. But however, this is not related, I'm not looking at the operability and forced entry right now. I'm focusing on building envelope performance in terms of separating indoor and outdoor environments or unconditioned spaces from conditioned spaces. Skylights and their components shall be designed, constructed, and installed so that they resist snow loads also. And where windows, doors, and skylights and their components separate suites from the remainder of the building, they shall be designed, constructed, and installed so that they control air leakage where required, forced entry, and easily operable. You see that when you're looking at the general performance expectation, you see the performance along the building envelope, and then you see the performance within the building. So when looking at building envelope, I'm showing you some of the building envelope. Storm doors, are part of the building envelope. However, they have very specific requirements. Storm doors for sliding doors and their components shall be designed, constructed, and installed so that when they are in the closed position, they resist wind loads, control air leakage to a minimum allowable 5 meter cube per hour per meter, and a maximum allowable 8.35 meter cube hour per minute. This is air leakage rates, so per minute. Resist the ingress. So the control air leakage is 5 meter cube hours. So the leakage rates of volumes within an hour per meter of that's related to the dimension of the storm doors, and a maximum allowable of 835 meter cube hour per meter. They need to resist the ingress of insects and vermin and be easily operable. The compliance with the performance requirements described in sentence 1 shall be to 4 shall be demonstrated by either complying with the requirement of subsection 974 or 975 and subsection 976, or be designed and constructed in conformance to part 5 of the building code, and part 5 is in volume 1. So part 5 is written performance-based approach, whereas the 9.74, 9.75, and 976 are all prescriptive provisions that you need to follow step by step in order to make sure you comply with the requirements of the codes. Thermal performance, let's go back to the presentation. Heat transfer performance, and this relates to the thermal performance, is the compliance with the heat transfer performance requirement shall be demonstrated again by complying with the requirements on Article 9733 or design and construction conforming to Part 5. And we can see it again here, 9732. Heat transfer performance, windows, doors, and skylights and their components described in sentence 9711 shall be designed, constructed, and installed to minimize surface concentration on the warm side of the component and ensure comfortable conditions for the occupants. So these are performance-based objectives in terms of minimum performance requirements. So you want to minimize surface condensation on the warm side, and you want to ensure comfortable condition for the occupants. How do you do that? You do that by demonstrating compliance with the requirements of Article 9733 or design and construction conforming to Part 5. Always you will see this allowance in the building code under Part 9. You can either design based on a compliance approach, an objective-based approach, performance-based approach, or you use the prescriptive provisions within Part 9. The prescriptive provisions here for heat transfer performance is 9733, and here for general compliance requirements for windows, doors, and skylights for these types of ingress is 974, 975, and 976. So 9733, if you look up in 9733, it talks about the thermal characteristics of window doors and skylights. So if we want to go to the prescriptive approach, we're gonna have to find out the maximum thermal transmitters U values for windows, doors, and skylights. And when you don't have high generation of moisture, if your building generates high moisture, you definitely have to go to part 5 and use a performance-based approach for that building, because you're going to be needing a lot of engineering and evaluation to be able to and of the materials, as well as calculations to make sure that you are protecting your indoor environment appropriately. If otherwise, you can use 9733 and windows, doors, and skylights in areas where, and that's the second point that's in, and the notes addresses it. So it will send you to 5.3 for high moisture generation areas. Otherwise, for other areas where you don't have high generation of moisture, you can use the 9733. And in all cases, you have always the option of going and applying part 5 and to design your building, your heat transfer performance for the window, doors, and skylights. So this is the maximum U value of or minimum temperature index for windows, doors, and skylights. I've got windows and doors. You can see we looked that up between -15 and -30. The maximum transmitted U value for windows and doors is 2. For skylights is 3. And this climatic design provisions within the buildings, I have different information related to climatic data, which I will be using later on for classifying my materials, or depending on the region, and using values in calculations that I'm for thermal performance, energy efficiencies, and also some of the for snow loads and hourly winds. We're going to be using them also for structural performance.
Excuse me, can I ask you something?
Yes.
So in the design temperature, we have for January we have 2.5 and 1%. Which one we should use to design?
Can you repeat the question, please?
Yeah. So in table C2.
Yes.
On design temperature.
Yeah.
For January, we have 2 different temperatures, 2.5 or 1%.
Yes.
So which one we should use?
We're to the 2.5%.
2.5.
That's basically on the application. When we looked at the application, we said that 2.5%. Okay. For winter temperatures. For summer temperatures, it's the July 2.5%. But most of the design criteria and the thermal performance, you're going to see it is based on 2.5% in January. But the code will tell you, will ask you.
Okay.
Yeah, but as we have seen in part 1 on the application, in part 1 division B on the application of the climatic data, that's based on January 2.5%.
Okay, thank you.
Okay, we've done that. Manufactured windows, doors, and skylights. There's specific performance requirements for them in terms of they need to meet the specification for the AMA specification, and they need the manufactured ones needs to meet the harmonized standard, which is the AMA standard for fenestration products, as well as the Canadian supplement North American Fenestration Standard specification for window, doors, and skylights. They need to also comply with subsection 974 and the applicable requirements in the subsection 976. So these are all for manufactured and pre-assembled windows, doors, skylights, and their installations. The minimum level of performance required for windows and skylights shall be the performance level R. So this is in terms of classifying the windows. You've got different performance levels in the standards, and the one that you're going to be picking for the performance from the standards, you're going to be looking at performance level R for windows, doors, and skylights. And the performance grades shall be selected according to Canadian supplement as appropriate for the conditions and the geographic location in which they shall be installed when tested in accordance with the Canadian harmonized standards. So we have a Canadian harmonized standards. If you see fenestration products only to the American standards, that will not be acceptable. You need to make sure that you're using the version of the AMA, WMA, CSA 101 that is harmonized standard and also the Canadian supplement for the performance grades that to be assigned to them, because they definitely need to be tested and have performance grading in accordance with the Canadian provisions. So so they go hand in hand. So that's CSA A440 SL. Site build windows, doors, and skylights. So that what we would have looked before at the manufactured windows, doors, and skylights. For site built windows, doors, and skylights, we've got the provisions in 975. Let's take a look at 975. Materials, design, construction, and installation of window, doors, and skylights that separate conditioned space from unconditioned space or the exterior, but are not covered in the scope of AMA, DMA CSA 101 IS2 A440 NAFS specification standard for windows, doors, and skylight. They shall conform to the remainder of subsection 9.74, the applicable requirements of subsection 976, or they shall meet the requirement. They shall be designed and installed and constructed in accordance with the provisions of Part 5, which is a performance-based approach. The glass for site-built windows, doors, and side lights shall comply with Section 9.6 for glass. So again, here we are sent to Part 5 for site-built windows, doors, and skylight. We have specific provisions for resistance to forced entry of doors. And the installation for the site ones, the installation for windows, doors, and skylights shall conform to the standard CSA 8440.4, except there is some exceptions for shims and protection from precipitation. You need to provide it in conformance with 9.27 for roof and for walls and windows and doors and walls, and for skylights and roof, and the interfaces of the walls with windows and doors and roofs with skylights. So the installation of manufactured and pre-assembled windows, doors, and skylight, and the field assembly of manufactured window and doors combination unit shall conform with to the manufacturer's instructions. The windows, doors, and skylights shall be sealed to air barriers and vapor barriers. So this is critical, is that for manufactured pre-assembled window, doors, and skylights, you gotta also make sure you install them to the requirements of the manufacturer instructions. And you have to make sure that the doors, skylights, and windows are sealed to the air barriers and vapor barriers. There's requirements to sealants, trim, and flashing. The sealants compound used to seal the glass component of an insulating glazing unit to the sash component shall be compatible with the sealing compound. Flashing used to protect the opening needs to meet the articles in 927, 37, and 38. Sealant shall be applied between window frames or trim to the exterior cladding on masonry in accordance with 927.4. This is where you see this is all cookbook recipes, prescriptive requirements in terms of application of site installation of window, doors, and skylights. So no matter what you're designing it and providing the installation, when you're getting to the installation, you have to make sure that you're meeting those requirements. So the performance provisions are related, you're sent back to Part 5, application and compliance. When you're getting to 976, in terms of installation, you're not sent back to Part 5. There's specific requirements you need to meet here and to make sure you're complying. So, okay.
Can I ask a question, Amal?
Go ahead.
It's maybe a silly question, but how do we know for like a Part 3 building?
Yeah.
Because this is like the Part 9 information on all of this materials. It's very, very detailed.
Exactly.
For a Part 3 building, we just know that then it's designed to Part 5 or Part 4 for structure, which is less detailed maybe, but more stringent. I don't.
Yeah. I mean, if you want to take a look at it, in terms of part 5, the way it's talking about the installation, if that's in volume 1, if just to compare the statements in part 5. So I'm looking at part 5, and let's take a look at part 5 together.
Sorry to detour.
It's good. No, it's not a. Yeah, I mean, this is good. This is to show you how things are different in the building code. The approach in the part 9 is very. It's a specification of how to build, right? Whereas in part 4, part 3 building, it's more performance-based approach. So let's look for environmental part 5. Environmental. Okay. All right. So it's very brief in terms of provisions. Environmental separation. This part is concerned with the control of condensation in building components, materials, and assemblies, and on building materials, components, and assemblies. The control in and on. So you got to be careful with that. The transfer of heat, air, moisture, and sound through building materials, and the interfaces of building materials, components, and assemblies. So it tells you this is what an exposure to exterior space or the ground, or separation of different environment. This part applies to building materials, components, and assemblies exposed to exterior space or the ground, including those separating interior space from exterior space and separating interior space from the ground. And then it goes on for dissimilar interior spaces and environmentally dissimilar interior spaces, and site materials, components, assemblies, and grading that may affect environmental loads on the building materials, components, and assemblies exposed to exterior space or the ground. So now here, it's all it says it shall be demonstrated, shall perform more on one function, shall be demonstrated that they with regard to materials, associated loads, air pressure loads imposed on air barriers, so shall be demonstrated by design complying with subsections 522. So you got to demonstrate it, you got to do the calculation, you got to look loads, evaluate loads, you demonstrate resistance to deterioration, and you demonstrate performance and resistance to structural and environmental loads. So it doesn't tell you how to evaluate them, or it does not prescribe what those loads are. It just tells you the procedures. In terms of climatic values, you go back to 113. If you're looking at environmental loads that are not described, you look at geological and hydrological data, indoor environmental loads. So with good practice, environmental load and transfer calculations, you look at the ASHRAE handbook for transfer of heat, air, and moisture, and sound. Also, you look at good practice, structural loads, and design procedures for those materials in the envelope environmental protection. Again, the structural loads refer to dead loads transferred from structural elements: wind, snow, rain, hydrostatic, and earth pressure. So and then again, everything is based on best practice. And we're coming to thermal resistance. Again, it gives you the performance provisions that the installation of material is to resist heat transfer in accordance with the remainder of this subsection is not required, where it can be shown that uncontrolled heat transfer will not adversely affect any of the health or safety of building users, the intended use of the building, and the operation of building spaces. Building services. So if you can do demonstrations and that it will not affect, then you don't have to worry about doing the calculations. Properties to resist heat transfer, dissipate heat. It gives you the properties. And then location and installation of materials to providing thermal resistance. It tells you that in those areas, you got to make sure that you have proper thermal resistance. And then again, for air leakage, you need to demonstrate that you minimize air leakage in the building, you control heat transfer to roofs where ice damming occurs, and then it gives you some air barrier system properties. And same thing with vapor diffusion. So it doesn't tell you how to install them. It doesn't tell you where to install them. It tells you what it needs to control and what are some of the standards and test methods to use, or specifications, general guidelines in terms of doing calculations and design for those. So, but it identify all the different loads for, and how they are to be addressed, but without telling you how to do it. It doesn't tell you when you're designing your wood frame construction, it's going to do this. When you're designing your foundation, it's going to be constructed as such. And so it doesn't go into the detail of Part 9. So it's all performance-based performance design, and I think with that, I don't want to go more into Part 5. With what I have showed you, I hope that it illustrates the difference between Part 5 and Part 9. Does it?
Yeah, thank you.
Does
That's
it show
great.
it?
Appreciate that.
Yeah.
Amal, can I have a question? Quick one. It was related to a slide where you were showing the table 9.7.4 in Division B.
974?
Yeah, I couldn't find the table. No, it's
Where is that?
next slide. Yeah, next one. Yeah, here.
It's in subsection 974.
Sorry, maybe is it
Section?
9.7? Yeah.
Manufactured window doors and skylights. That's
No, I think there
974.
was a table. There was a table that you were showing.
Yeah. Ah, you mean was it the table that I was showing? That's the one before,
Yeah,
9733. Yeah,
9733.
yeah.
Uh, okay.
Okay.
And the table C2.
The table C2 is from, it's in volume 1.
Volume 1. Yeah.
Yeah, this is the climatic data. Remember, right before
Yeah.
Appendix D, fire and fire performance, and right after, um, let's see, Appendix C is gonna come after Part
After
8. Yeah.
yeah, Division
You
B
see it?
part 8.
Yeah.
Yeah.
Okay. That's the climatic data.
Yeah.
So we talked about
Thank you.
site-built windows. You're welcome. Excavation. Well, let's take a look at excavation. You've got general depth backfill, trenches beneath footings. Let's take a look at that. We can take a look at it quickly. Let's do that. 9.12.1. You see here all the objective and functional statements related to all the provisions. It's related to F60, safety, protection, and health. But we're gonna go over there at the end of the session. 9.12. Okay, perfect. So excavations, the topsoil and vegetable matter in all unexcavated areas under a building shall be removed. Okay, so if you have unexcavated areas, you want to make sure under the building, you need to remove the topsoil and vegetable matter. And in localities where termite infestation is known to be a problem, all stumps, roots, and other wood debris shall be removed from the soil to a depth of not less than 300 millimeter in unexcavated areas under a building. So if you know you've got problem with termites, and if you have all the stumps and all stumps, roots, and all wood debris need to be removed from the soil that is unexcavated, and the bottom of every excavation shall be free of all organic matter. Excavation shall be free of standing water, protects it from freezing. The bottom of excavation shall be kept from freezing throughout the entire construction period. Excavations for foundation shall extend to undisturbed soil, and minimum depth of foundations, except as provided in sentences 4 to 7, the minimum depth of foundation below finished ground level shall conform to table 912.22. So if you have rock and you have good soil drainage, you don't have a limit on the depth. If you have clays or soils that are not clearly defined, so if you don't know exactly the nature of your soil, you have to have a minimum depth of foundation containing heated base for if it contains a heated basement or a crawl space of 1.2 meter. If you have good soil drainage or poor soil drainage. If you have no heated space, you gotta have it at least 1.2, but not less the depth of the frost penetration. So you want to know what's your frost penetration. Same thing with poor, good soil drainage and poor soil poor soil drainage. So same thing for your silts. You want to make them below the depths of the frost penetrations for silt grounds. For coarse grained soil, it's if you have poor soil drainage, you need to be careful, and you want to have a minimum depth of your foundation for unheated spaces in the foundation basement levels. You want to make sure that the depth of the frost, it's below the depths of the frost penetration. Where a foundation is insulated in a manner that will reduce the heat flow to the soil beneath the footings, the foundation depth shall conform to that required for foundations containing no heated spaces. So if you're using insulation and the foundation is insulated, so that the heat flow to the soil beneath the footing, the foundation depth shall conform to that required of foundation containing no heated spaces. The minimum depth of foundation for exterior concrete steps with more than 2 risers shall conform to sentences 1, 2, and 5. So again, exterior concrete steps will be treated as foundation in these conditions. And the foundation depth required in sentence 1 are permitted to be decreased where experience with local soil conditions shows that lesser depths are satisfactory. So there is professional judgment here, or where the foundation is designed for lesser depth. So, and the foundation depths required by sentence 1 do not apply to foundations for buildings that are not of masonry or masonry veneer construction. So the foundation depths required by sentence 1 do not apply for foundation to buildings that are not of masonry or masonry veneer construction and whose superstructure conforms to the requirements of the deformation resistance test and CSA Z242.1 structural requirement for manufactured homes, or accessory buildings that are not of masonry and or masonry veneer construction, not more than 1 story in height, not more than 55 meters square building area, where the distance from finished ground to the underside of the floor joist is no more than 600 millimeter. So there is exceptions you need to be aware of. The foundation depths required by sentence 1 do not apply to foundations for decks and other accessible exterior platforms of not more than 1 story, not more than 55 meters square in area, where the distance from finished ground to the underside of the joist is not more than 600 millimeter, not supporting a roof, and not attached to another structure unless it can be demonstrated that a differential movement will not adversely affect the performance of the structure. Where decks or other exterior platforms are supported on surface foundations, supported on other than coarse-grained soil with good drainage or rock, access to the foundation positions to permit releveling of the platform shall be provided. So you need to provide access when you are supported on other than coarse-grained soil with good drainage or rock. So the access needs to be provided by passageways with a clear height under the platform of not less than 600 millimeter and a width of not less than 600 millimeter, or by installing the decking in a manner that allows easy removal in order to address the conditions of the soil underneath it. Let's see. Footings in 912. And you're looking here at backfills and placement of backfills, trenches beneath the footings, support of the footings, and these are all related to the design of your depths in terms of excavations and protection from the soil, depending on the soil conditions of your underneath your building. Let's see. Dam proofing, waterproofing, and soil and gas control. These are also elements of the envelopes that you need to address, and that's under section 9, subsection 913.3. You've got a 913.1. You've got general and scope and application. If you look at that, let's see, did I address it? Not really. How are we doing? 123. Okay, we're not going to go through it. I just want to make sure that we get into the next section. So we have general scope and application, dam proofing, waterproofing where required, soil gas control. I will cover only the general scope and application. Okay, 913. Okay. This section presents measures to control the ingress of water, moisture, and soil gas. When we're talking about soil gas, it's mostly we're talking about radon, but we'll see that in general you need to you need to provide protection depending on the condition of your soils. Section 913.2 applies to below ground walls and floors on ground where drainage is provided in accordance with section 9.14 over along the entire below ground portion of the foundations. Subsection 913.3 applies to below ground walls, floors on ground, and roofs of underground structures that are subject to hydrostatic pressure. And 913.4 applies to walls, roofs, and floors that are in contact with the ground. Dam proofing. So where the required dam proofing, where the exterior finish ground level is at a higher elevation than the ground level inside foundation walls, exterior surfaces of foundation walls below ground level shall be dam proofed. And flows on ground shall be dam proofed, and dam proofing required need not be provided for floors in garages, floors in unenclosed portions of the building, and floors installed over not less than 100 millimeter course of clean granular material containing not more than 10% of material that will pass a 4 millimeter sieve. So dam proofing is not required under floors in garages, is not required in unenclosed portions of the buildings. And if you have floors installed over a specific type of ground with not less than 100 millimeter coarse clean granular material containing not more than 10% of material that will pass a 4 millimeter sieve. And then you got the performance requirements and the standards that for dam proofing materials. Dam proofing materials must be capable of protecting assemblies against moisture transfer from the ground, compatible with adjoining material, and resistant to mechanism of deterioration that may reasonably be expected given the nature, function, and exposure of the material. And you've got different type of dam proofing materials and standards. And it's got specific performance for vapor performance, vapor permeance, in accordance to ASTM E96. It goes over the preparation of surface, the application of dam proofing material, moisture protection from interior finishes, and dam proofing of floors on ground. And then we go into waterproofing. Into waterproofing, you have where it is required, where hydrostatic pressure occurs, waterproofing is required for assemblies separating interior space from the ground to prevent the ingress of water into the building assemblies and interior spaces. Waterproofing is required for roofs of underground structures to prevent the ingress of water into the building assemblies and interior spaces. Again, it lists the different materials to be used, what are the expected performance as well, and you go into the preparation of the surface, the application of the waterproofing membrane, floor waterproofing membrane, and then 913.4 is soil gas control, application and scope, protection from soil gas ingress, providing for rough-in as for a subfloor depressurization systems, and then we go into drainage. Let's see where we are on the presentation. we've got waterproofing, soil gas control. You've got other components and systems relating to performance of the building envelope. You've got your drainage system, your footings and foundations, your floor and grounds has got specified construction, installation, columns, crawl spaces, roof spaces, roofing, cladding, stucco, garage, and carports. All these elements will have different provisions. So this is rain screened in behind cladding, in front of cladding, depending on rain penetration to control. You've got first plane of penetration of protection, which is your cladding. Second plane of protection, airspace sheathing membrane. So this is talking about some of the elements of 9.27 related to different planes of protection against rain penetration. And this is from the Illustrator's User's Guide. It gives you some examples of rain screen assemblies. Heat transfer, air leakage, and condensation control. This section is concerned with heat transfer, heat, air, and water vapor transfer, and measures to control condensation. All walls, ceilings, and floors separating conditioned space from unconditioned space, the exterior air or the ground shall be provided with thermal insulation conforming to subsection 9.525.2 and section 936. An air barrier conforming to subsection 9.253 and section 9.36, and a vapor barrier conforming to subsection 9.254, and constructed in such a way that the properties and relative position of all materials conform to subsection 9.255. Insulation and sealing and of heating and ventilation ducts shall conform to 9.32, 9.33, and 9.36. This is relating to heat transfer, air leakage, and condensation control of the building. This relates to the scope and application of such provisions. So for thermal insulation, all walls, ceilings, and floors separating heated space from unheated space, the exterior air or the exterior soil shall be provided with sufficient thermal insulation to prevent moisture condensation on their room side during winter and to ensure comfortable conditions. Installation materials will have material specification standards, flame spread ratings, requirements from the standards do not apply. Insulation in contact with the ground shall be inert to the action of soil and water and shall be such that the insulative materials are not significantly reduced by moisture. So you go into the thermal insulation, their expected performance, what are the insulation materials, what material specification standards to use, and then it goes into the installation of the thermal insulation. Same thing for requirements for air barrier for air leakage, where they are required, what are the system properties, the continuity of the air barrier system, and then the air leakage control for air barriers, where do you install them in masonry walls, underground structures, roof, air barrier system in floors on ground. And then you have required the barrier for vapor diffusion, where you are providing those. And finally, that's when we did vapor diffusion, vapor barrier materials, and installation of vapor materials. We are running out of time. I went a little bit quickly through this. These are all prescriptive provisions of the code and related to heat transfer, air leakage, and condensation control. So vapor barriers, air barriers, thermal insulation, and then sealing and insulation of heating and ventilation ducts. This is what this section addresses. So it's section 925. It's an important section. It gives you specific requirements. It references you to the standards applicable to each of the materials and where to install them in buildings where around certain building components. Construction materials and systems, definite resources for you in terms of the prescriptive requirements, part 9 of how to build certain systems. And we saw that we've got wood frame construction, we've got insulated concrete forms, we've got columns, we've got roofs, we've got roof spaces, we've got cladding, we've got roofing, we've got sheathing. All these elements are, are addressed into the notes at the end of Division B, Part 9. And also you have another source, the Illustrated User's Guide for NBCC 2015, Part 9. Construction material and systems. In 931, the Part 9 addresses the concrete, and it talks about concrete batching as well as concrete properties for use under Part 9. 932 talks about lumber and wood products, minimum lumber grades for specific uses, panel thickness tolerances, undersized lumber, termite and decay protection requirement for lumber. 933 talks about metal that is used in construction of Part 9 buildings, and glass is covered under 9.6. Construction systems relate to masonry insulating concrete form walls not in contact with the ground, masonry and concrete chimneys and flues, fireplaces, wood frame construction, sheet steel stud wall framing, roofing, cladding, stucco, interior walls and ceiling finishes, and flooring. Functional statements and objectives are provided for each one of those elements in Part 9. Before I go that, I want to just go into section 931, 932, and 933. Let's take a look at them. So if you can open your code book, please, under 931 concrete. So in concrete, except I've provided in sentence 2 on Articles 9316 and Article 9317, unreinforced and nominally reinforced concrete shall be designed, mixed and placed, cured and tested in accordance with the requirement for R-class concrete stated in Section 9 of CSA A2.23.1, Concrete Materials and Methods of Concrete Construction. So when you're except as provided, so you got to look at the exception in sentence 2. Unreinforced and nominally reinforced side batch concrete shall be designed, mixed and placed and cured in accordance with 9312 and 9319. So you can use side batch concrete, but if you're going to use it, you got to make sure that you meet the requirements of Articles 9312 to 9319. Except as provided in sentence 4, if you're using reinforced concrete construction, you need to design it in conformance with the requirements in Part 4. Except that for flat insulating concrete form walls not exceeding 2 stories in building heights and having a maximum floor-to-floor height of 3 meters in buildings of light frame construction containing only single dwelling units, the concrete and the reinforcing shall comply in Part 4, or the concrete shall conform into CSA A23.1 with a certain aggregate size of 19 millimeter, and the reinforcing needs to meet the reinforcement provisions of CSA G30.18 carbon steel bars reinforcements, have a minimum yield strength of 400 megapascals and be lapped over 450 millimeter for 10 M bars and 650 millimeter 15 M bars. So this tells you that there are exceptions for certain to use reinforced concrete only for 2-story buildings, not exceeding having a floor-to-floor height of not more than 3 meters, in buildings of light frame construction containing only a single dwelling unit. And then you can use either Part 4 or you meet the provisions of this of 93111. 114. So that's on concrete. Cement shall meet the requirements of CSA A3001. Concrete in contact with sulfate soil. Concrete in contact with sulfate soil, which is deleterious to normal cement, shall conform to the requirements of clause 4116 of CSA 23.1. Aggregates, they tell you, basically Part 9 tells you what kind of aggregates to use for concrete materials and cement. The water shall be clean and free of injurious amounts of oil, organic matter, sediment, or any other deleterious material. The compressive strength requirements, concrete mixes 9317 for premixed concrete and side batch concrete. Table 9317 for side batch concrete mixes. the maximum ratio of water to cementing materials measured by weight shall not exceed 0.7 for walls, columns, fireplaces and chimneys, foundations, footings, grate beams and piers, 0.65 for floors, other than those in garages and carports, and 0.45 for garage and carport floors. So this is for side batch concrete. You will see what for cementing material, the maximum size of coarse aggregates, and the parts, and then basically coarse aggregates, gravel and crushed stones in terms of parts. The size of the aggregate in unreinforced side batch concrete mixes refers in sentence 1 shall not exceed the 1/5 the distance between the sides of the vertical forms or 1/3 the thickness of the flatwork. Admixtures, we have also the standard for admixtures. What to do in cold weather requirements. And for lumber and wood, so when the air temperature is below 5 degrees C, concrete shall be kept at temperature of not less than 10 degrees C or more than 25 C while being mixed and placed, and maintained at a temperature of not less than 10 degrees for 72 hours after placing. No frozen material ice shall be used in concrete described in sentence 1. For lumber and wood products, again, we have this lumber for joists, rafter, trusses, and beams, and for the uses listed in table 9321 shall be identified by a grade stamp to indicate its grade as determined by NLGA 2014. So these are all the different grades, minimum grades to be used depending on the uses of the wood framing. The lumber grades, except for joists, rafter, trusses, and beams, visually graded lumber shall conform to the grades in table 9321. Machine stress rated lumber shall conform to the requirement of subsection 4.31. So this is for anything that's machine stressed lumber, you have to go to part 4, and specifically subsection 431. OSB wafer board plywood used for roof sheathing, wall sheathing, and subflooring shall be legibly identified on the face of the material, indicating the manufacturer of the material, the standard to which it's produced, and that material and the exterior type. We've got the moisture content of the lumber shall not be more than 19% at the time of installation. So you got to make sure that moisture contact is monitored. The lumber dimensions referred to in this part are actual dimensions determined in conformance with CSA 0141 softwood lumber. You've got panel thickness tolerances. The thickness specified in this part for plywood, hardboard, particle board, OSB, and wafer board shall be subject to the tolerances permitted in the standards reference for these products unless specifically indicated herein. So the thickness is specified for the plywood, the hardwood, particle board, OSB, and wafer board shall be in accordance with the standard unless specifically specified depending on the application within the building construction assembly. Then they will the building code will specify a certain thickness, and you have to comply with that thickness requirement. Undersized lumber, joist, rafter, lintels, and beam members up to 5% less than the actual Canadian standard sizes are permitted to be used, provided that the allowable spans for the grade and species of the lumber under consideration are reduced 5% from those shown in the span table for full-size members. So if we're looking at the span tables, you can look at, do you remember where the span tables are? Where are the span tables? Yeah.
Yeah, they are in volume 2. Sorry, volume volume 2. They are in volume 2, division B, page 9447. Sorry, yeah. They are right before the notes to part 9.
Yeah. So what this tells me, 9328, it tells us that if you're going to use joists, rafter, lintels, and beam members up to 5% less than the actual standard sizes that are permitted to be used, then you gotta reduce the allowable stands by 5% from those shown in the span tables. So if we are looking at for wood construction, so if we are looking for lumber, if we are looking for Douglas fir, Douglas fir larch includes Douglas firs and Western larch. That's on page 9455. We can use 5% if you're looking at the standard grade. And for the joist side of 38 by 89, the maximum span is this is for joist spacing of 600, you are allowed a 1.7 span, you have to reduce it. If you're using for 300 spacing, 300 joist spacing of 300 millimeters, what is that? Then you can use, for standard, you can use a 2.41 span, and then you can reduce for if you're using for the undersized lumber, if it doesn't meet the specific standard size, it's up to 5% less than the actual standard size. So it's 5% of 38 by 89 less, then the span you need to reduce it by 5%. So you see that?
No, Amal,
So,
sorry, could you do that
so
again?
if you can see, if you're looking at 930, for example, 923 4D, 42D.
Uh-huh.
Okay.
Yeah.
I've got table 9 for its maximum span for roof joist, specified roof snow loads, right?
Mm-hmm.
So if I've got the standard size, it's 38 by 89 for Douglas fir, right? It's 38 by 39. That's on page 9455.
5.
So this is for lumber. Any of the span tables for lumbers, you can actually do that. So it's giving you an allowance of 5% less than the actual Canadian standard. So the actual Canadian standard 38 by 89. So it allows you a reduction of 5% less in terms of the sizing of the lumber, and then if you reduce it up to 5% reduction in terms of size, so 38 by 89, so 5% of that is what? 5% of 38, and 5, so in terms of...
Sorry,
Sorry.
Amal, aren't you saying that it's the maximum span for roof joist and specified roof snow load?
Yeah.
It's 457, not 455.
Okay, that's basically you're in other in your bound document.
Another question.
In the binder, it's 457 for
Yeah.
the roof joist specified roof snow.
Yes. Yeah. So what there is allowances basically. If you reduce the member from its standard size up to 5% less than the standard size, not more than 5%, than that, then you can actually, you have to reduce the span that is listed in the tables for that specific lumber element by, the span needs to be reduced by 5%. That's what it says.
So
Otherwise,
example, you were showing us which that was Douglas fir, but which grade? You said 38 by 89, but is it number 3, number 1, and number 2? Which one?
the standard. I was looking at the standard. There is a standard at the bottom, You can look at select structural.
Okay.
You can look
Okay.
at number 1 and number 2, number 3, construction and standard. So it's just for illustration I'm giving you. And I mean, in terms of design, definitely you gotta have a design expert that is working with you on this. But in terms of the provision, application of the provision, you gotta be careful. If your members do not meet the standards, the sizes that are listed, and if they are no more than 5% less than them, then you have to reduce the spans to up to 5%. That's what it says. So termite and decay protection. In localities where termites are known to occur, clearance between structural wood elements and the finished ground level directly below them shall not be less than 450 millimeter. So this one where you wanted to protect wood elements above finished ground levels. Structural wood elements supported by elements in contact with the ground or exposed over bare soil shall be pressure treated with a chemical that is toxic to termites. So for those that are in contact with the ground or exposed over bare soil, you need to pressure treatment against termite. In localities where termites are known to occur and foundations are insulated or otherwise finished in a manner that could conceal a termite infestation, you need a metal or a plastic barrier installed through the insulation and any other separation of finished material above finished ground level to control the passage of termites behind or through the insulation, separation, and finished material. So if you've got an insulated foundation, or you have a foundation that is finished in a manner to conceal a termite infestation, so you won't able to see it if you have a foundation that is if you don't see the termite infestation. If you have certain types of foundations, you got to make sure that you've got a metal or a plastic barrier to cover the installed through the insulation and any other separation of finished material above finished ground. And all sides of the finished supporting assembly shall be visible to permit inspection. Structural wood elements shall be pressure treated with a preservative to resist decay. So this is in general decay, where the vertical clearance between structural wood elements and finished ground level is less than 150 millimeter. This is because where wood elements are not protected from exposure to precipitation, where you might have moisture accumulation and the moisture index is greater than 1. Again, structural wood elements used in retaining wall and cribbing shall be pressure treated with a preservative to resist decay, where the retaining wall or cribbing supports ground is critical, that is critical to the supporting of the building foundations, or retaining wall or cribbing is greater than 1.2 meter in height. Where wood is required by this article to be treated and resist termite or decay, so you have a decay, the weathering type of treatment, or termite resistance, such treatment shall be in accordance with Table 2, use categories for specific product, uses and exposure, or of CAN CSA 080.1 specification for treated wood. So you've got the category 1, UC1, interior construction above ground application where the wood manually remain dries. Use category UC2, use category UC32. So these are different categories of wood that is pressure treated for decay or termite resistance. You've got provisions for metal, sheet metal thickness. The minimum thicknesses for sheet metal material that are stated in this part refer to the actual base metal thickness measured at any point of the material. In the case of galvanized steel, it includes the thickness of the galvanizing coating unless it's otherwise indicated. And then it refers you to the galvanized steel sheet requirements for galvanized steel is ASTM 653 and ASTM A792. 653 for galvanized steel is for for hot dipped process, and ASTM A792 is aluminum zinc coated by the hot dip process. So while the galvanized sheet steel is intended for use in location exposed to the weather or as a flashing material, it shall have a zinc coating not less than G90 coating designation or an aluminum zinc alloy coating not less than AZM 150 coating designation as referred to sentence 1. A lot of problems come with galvanized steel exposure to the elements in Canada. You want to make sure that it's properly protected and it has a zinc coating not less than G90 or have an aluminum zinc alloy coating not less than AZM 150 coating designation. So we went a little bit quickly through the materials. Want to make sure that we go over some of the provisions related to objective and functional statements. Okay. So we were looking at 9.1. Let's see that. Yeah. Page up. So we looked at footings, we looked at foundations. So you see here all the different functional statements and objectives associated with Part 9 provisions are all listed in the attribution tables of section 9.37, and you will see that for concrete aggregates, you've got F20, OS 2.1, F80, OS 2.3, F20, OS 2.3 applies to elements that support or are part of an environmental separator. Do you remember where to find those functional statements and objectives? We did that in part 3. For those of you that participated in part 3, do you remember? We said we have to use division volume 1, division A. We have the definitions of the functional statements, and we have in division A in part 2, we have the definitions of objectives. So part 3 in division A, we've got functional statements. In part 2 in division A, we've got objectives. If you can go there and please tell me what is the functional statement associated with F20. Khadija, you have a question?
Yes. I don't know if you already answered it, but when we were discussing about the foundation and the dam proofing and waterproofing section on part 9,
yeah.
Question is like, are those requirements only applicable for the part 9 buildings, and we have a similar section for part 3 building as well, or like
no, this is all for part 9 buildings.
Okay.
Yeah.
So we have similar requirement section on part 3 as well for those?
And for part 3, so if part 3 is fire protection requirements. So part 5 applies to all buildings related to environmental separation.
Mm-hmm.
And then for the design of your foundation is part 4. But definitely you have to use part 4 and part 5 together. And it's a performance-based approach and references design standards. It's not a prescriptive, statements to tell you how to build your buildings. So careful. Some of the provision apply only to dwellings in part 9, but when it comes to those types of provisions, when we're looking at waterproofing and dam proofing, it applies for all buildings and under part 9.
Okay, got it. Thank you.
Sure. So did somebody tell me what's F20 and F80 in chat?
F20 is to support and withstand expected loads and forces.
Yes, thank you. And F80, someone else?
F80 is to resist deterioration resulting from expected service conditions.
Excellent. Okay. So, and if we go to the objective statements, OS OS 2.1, the objective associated with that is OS 2.1.
The OS 2 is structural safety, and OS
Yes.
201 is load bearing on the building elements that exceeds their load bearing capacity.
So yeah, the objective of the code is to limit the probability that as a result of the design and construction of the building, a person in or adjacent to the building will be exposed to an unacceptable risk of injury due to structural failure. The risk of injury due to structural failure addressed in this code is caused, in this case, by load bearings on the building elements that exceed their load bearing capacity. So this relates to the structural safety of people in and adjacent to the building. And 2.3 is for based on damage or deterioration of the building elements. So that's where you're causing potential risk to the people within the building and adjacent to the building by causing structural failure. So any questions related to what we just covered? I'm sorry that we're going very quickly, but the intent here is to make you familiar with the code provisions and applying them, understanding some of the nuances related to those. We're with the time that we have, we cannot go through all the provisions related to structural design in part 9, but hopefully we've introduced enough concepts for you related to that and showed you some of the important sections and references that you need to go to for those elements. You have structural performance design requirements specific to different components of the building in part 9, and these are spelled out under the different sections that are identified in the presentation. Any question?
Thank you. We hope that you've enjoyed this session. For additional continuing education opportunities, visit the www.raic.org/continuing education.